In this exercise, we are given a closed set, and the task is now to prove that the closed set is satisfiable. And we are supposed to use the resolution algorithm for that. How can the resolution algorithm prove a closed set to be satisfiable? Well, we have to try to apply all the possible resolution steps. And if we cannot generate the empty close meanwhile, and we really tried all the possible resolution steps, then at the end, we can say that, yeah, this closed set is not unsatisfiable. That is, it is satisfiable. But really, what we really need to try to apply all the possible resolution steps for that. Okay, so let's get started. Let me start with clauses number 1 and 2, and this is how I generate clause number 5. When you resolve clause number 1 and 2, you are going to eliminate B and not B, so the resolvent is going to be not A. Okay, in the next step, we can try to resolve the clauses number 1 and 3. And in this case, again, B and not B are going to be eliminated, and the resolvent is going to be A or not C. Okay, what's next? Let's try to resolve clause number 2 with clause number 3. And yeah, this can also work because of those two literals. And let's see what the resolvent looks like. Not B or not B or not C. Well, in this case, we can simplify the resolvent a little bit because it has a duplicated literal. We can just remove one of the duplicants. Okay, in the next step, we can try to resolve clauses number 2 and 3, 4. And the resolvent is going to be not A or C. Okay, in the next step, let's resolve clauses number 3 and 4. And in this step is quite interesting because now we can notice that those two clauses contain two pairs of resolvable literals, not B and B, or not C or C. So the question arises, can we eliminate both pairs of literals during a resolution step, or we can eliminate only one of them? In fact, we can eliminate only one of them based on the definition of a resolvent. So we have to pick either not B and B or not C and C. Let's say I pick not B and B, and therefore the resolvent is as follows: A or not C or C. And this clause seems a little bit strange because it contains two contradictory literals. So this part in the clause equals to 1. Therefore, we can simplify the resolvent to A or 1, which can further simplify to 1. So basically, I just generated a resolvent which is always true. And this does not have too much because, you know, the original question is if my closed set is satisfiable, which means if all the clauses can be made true at the same time. And this clause is always true, so this resolvent does not help at all. And actually the same, I get a very similar resolvent if I pick not C and C, and the resolvent will be 1 again. So what is the message here? The message here is that whenever you find two clauses which contain more than one pairs of contradictory literals, then don't apply the resolution step to those two clauses, because you will get a clause which is always true, and this does not make any progress. So we can just ignore this resolution step now. Okay, let's keep going. Let's pick clauses number 3 and 5. 3 and 5, 3 and 5. So in this case, we are going to eliminate those two literals, and the resolvent is going to be not B or not C. Not B or not C. I made a mistake before. I just realized that here, when we resolved number 2 and 3, the resolvent should have been not B or not C exactly. And therefore, I've just generated the same clause, which does not make sense. So we can just ignore this step as well. Okay, what's left? So the possible resolution step is to resolve clauses number 4 and 6. 4 and 6, sorry, 4 and 6, exactly. So now we can resolve out C and not C, and the resolvent is going to be B or A, which is a completely new clause, so we can keep it. Then we can try to resolve clauses number 5 and 6, exactly, and then there the resolvent is not C, which is also a brand new clause. And I forgot to use the numberings here. So this is clause number 9, clause number 10, right? So by looking at those clauses, I can see one more possible resolution step with clause number 8 and clause number 10, where the resolvent would be not A, but this does not make too much sense either, because not A was already generated before, so this is also a resolution step which can be ignored. And I don't see any further possible resolution steps. So we tried everything, and we could not derive the empty clause. And this proves that the clause set is satisfiable. We tried every possible steps. We generated all the possible clauses, and we cannot generate more of them, because there are no further possible resolution steps. This clause set is saturated. This is an official term for this situation. If your clause set gets saturated, then you proved, and meanwhile you did not derive the empty clause, then you know that your clause set is satisfiable.